Hello and welcome to this Magna-Matic video. We're taking a little field trip today. We're at Zinc Tech down here in Palatine, Illinois, and we're going to take you on a little tour to show you the new die casting mold and the die casting process for our blade balancer aluminum bracket. This is the wall bracket that the balancer is normally mounted in, and we've got a brand new die we're seeing run for the first time to get a higher quality base bracket with the American flag featured in it, newer lettering, and we're going to take you on a little tour to see that process today. We're now inside Zinc Tech with Manny here, who worked on our project for the balancer casting. We're using it as our mic stand today. And Manny's going to give us a little tour. You want to give us a little, just a quick short history on Zinc Tech? When did the company start?
The company started back in 1966, I believe, out of Chicago. Various transitions of where they were established. They moved to Elk Grove, and then over here back in '85 is when we came to this location.
Fantastic. Well, now we're going to take a little shop tour, so head on along with us.
This is our quality. So anything that gets cast, anything that gets cast new or is in production wise, we do some checks, normal hand gauges, and then new stuff we use our CMM for to get PPAPs and fares going.
Yep.
Your casting was on there as well, getting dimensions done. And then
so again, validating all the dimensions when the part's manufactured and just ensuring that you're holding the tolerances that the customer's requested.
Correct, yes.
Beautiful.
And that's about it. I mean, we have two gentlemen that work in here. One of our is our interim quality assistant, and then also he's in charge of the CNC.
Okay.
And then we have an incoming inspection as well that gets documented over here.
Beautiful.
So, yeah. This is our tool room as we go down here. These are some of the machines that we had left over from when we had a bigger tool shop.
Sure.
When it first started. We do a lot of support, everything we can do to support our molds. Core pins if they need to be made. Anything that's elaborate, then we go back to the source that made the tool, primary tool.
Yep.
But anything we can do in-house, we do.
Do you do some of the like cleaning up and refinishing of the tooling, or kind of refreshing?
We do that after every run. We do just a general cleanup and then die prep for the next run. So
gotcha. Sure.
There's nothing, we don't take dimensional checks or anything like that, other than from the casting. But everything remains the same unless there's something broken that we repair if we can. You know. So this is a tool room. We do some stuff as well, secondary operations for our castings for customers. Tool room. These are new inserts here from. These are some new inserts that we just had done.
Okay.
But the coating that you see on here is exactly the same coating that we had done to your mold. Okay. This is a protective coating and helps with the longevity of the tool. So wear and tear. When I say wear and tear, it's mostly the wear of the material coming into the casting.
Sure.
Helps prevent it from eroding quicker. So
and I imagine that also lets the material let go easier, or let go of the aluminum easier.
It has a little bit of lubricity added on there. So that's just so you see how the coating is.
Right. Yep. Not that it's just raw steel.
Correct. Yeah.
Yep.
We have 18 keys going on for secondary.
Secondary ops.
Yeah.
Yep.
Just like you guys in house.
Yep.
Do some manual. Stuff that inventory that's going to be machined and staging. So that gets the same pummel blast. This is actually line blasted. But the same kind of blasting that your casting gets done, these get wet painted then after.
Okay. Looks like you guys are fans of Haas machines as well.
Yeah, you know, We bought these, but yeah, we started with 2 of them, and then we just added all these. General machine.
Yep.
We don't do any turning. You guys turn?
Yeah. Yep. Yeah, we've got so many shafts and pulleys and things like that. We turn all our internal machine parts and mill everything.
There's one thing we never got into is turning.
Well, that's probably not too common in castings, really. Would you think, or?
Well, you know, a couple applications it would be nice, but no. I mean, it's generally you can do everything on a vertical.
Right, they're always odd-shaped parts where you're usually making flats or popping holes, or
yeah. So this is all die storage here. This is, they're just using this right now for as a repair the machine, but this is all die storage. So when your mold gets done, it gets placed over here. Raw material. This is for zinc, though.
Okay.
I was just showing that this is powder coated as well, but this is zinc. You get more outgassing than zinc.
Oh, really? Okay.
This is our #1 aluminum machine. They're repairing the furnace for us. This is a 650-ton machine. And then the one over here where your part is on is a 450. Casting. Stay on this side over here because it's hot.
Sure.
See the process.
Dive in here.
Keep you away from this machine because this is running too.
Also hot. Yep.
Yeah. So the process is basically when he opens up the door, I'll explain what's going on. This is just the end of the process, taking the casting out. Now he's going to go in there and spray a dye lube on there to help the casting come out of the mold when it's done. So he sprays both halves. When he gets done, the door will close. He'll manually take aluminum out of the well over here, feed it into the plunger. And you'll see the rod move forward.
Okay.
That makes the shot. The door opens, you get your part out. And then the process repeats.
You can stand over there when he grabs the aluminum. Just watch the heat.
Mondo, put one over here. Don't touch the casting when it comes out.
Yeah.
I just told him you can place one over here.
Yeah.
So you can see it.
So tell us a little bit about why is there all this extra aluminum around the outside of it?
Okay. So in order to fill the casting, we have to, these are weighted cups. So your casting might weigh less than a half a pound or whatever. So we might have like a pound and a half of metal in that cup. So to get accurate, fill within the cavity. So we have here, these are the overflows, and that's what we call as the biscuit. The biscuit is the end portion of where the material comes in, and that gets all trimmed off. That gets all recycled, and then you have your remaining, you have your part. You need all this to get all the gases out of the mold. We have the overflows with the venting, and that pushes all the gas out of the mold in order to get it compact, the casting, to get a good solid casting.
Yeah, so that even density and
correct, yeah.
material throughout.
Yeah.
they want to see that turn into them.
Okay,
The guy said, yeah.
You have some there?
Yeah, yeah, a couple.
Yeah, give me 1 minute and we'll go down there.
Pressure. Not high pressure.
I think that's a better question for him, but I think we're shooting at 2,000 PSI.
Why is it a straight shot and not just pressure? Why does it hit?
Okay, so what you're doing is there's a shot sleeve. I can show you what the shot sleeve looks like. It's basically a tube. When you pour the metal in there, you can't just fly right away. You're actually pushing the metal and compacting it towards until there's like resistance. You get some of the air out of it, and then you send it home. Basically, you're pushing it and sending it home.
Get that last air and everything out.
And then at the end, when it's holding there, it's giving a little pressure to compact it. Yeah. And then the follow through helps with pushing out the biscuit. Yeah, you can't start fast because then it's like a wave in there. You know, you get the turbulence with all the metal. So you're actually just feeding it closely until there's calculated out until you're packing the die already, and then you hit it home. You want to see the trimming?
Yeah. You got a pretty good shot of pouring and stuff? Cool.
Thanks, Mando.
Thank you.
So this is your trim die. Sorry. Your trim die. That's the nest. If you flip it over, you can look underneath there. The die cutting section. So obviously we wait till the casting's cooled off. Nest it on your nest. Process removes the gating, the overflows, so you just have the part remaining. Yep. Right. You want to see more?
Sure, yeah.
So any of the scrap that comes off of there, especially the solid parts like the biscuit, that gets all remelted. Any of the overflows, usually we just send that back to recycling.
Okay.
So he's putting on a little bit of kerosene right now, so you don't get that. What we don't call friction welding, but if you just constantly use the cutting edge on the aluminum, you're going to get some galling on there.
Right.
So we're using a little bit of kerosene to lubricate the die cutting area, and then that helps with cutting.
Beautiful.
So you don't get buildup on the steel on the cutting edges, which in turn leaves marks on your casting.
Gotcha. And when you recycle the gates and stuff like that, why do you recycle the other material? Is it just because it's so thin and it's not worth remelting where the biscuit has more on it?
Okay, so these we recycle because it's solid. When you have those other pieces, sometimes it winds up on the floor and you don't want to take the dirt with it and put it back in your pot.
I gotcha. So it's more about contamination rather.
Yeah. Usually we have a bin over here, and you just cut it in half so you can see how solid the casting is for you.
Gotcha. It's a test for density.
Exactly. Yeah. But as I was saying, so that when you're having normal operation, the guy might be blowing them, they're falling on the floor, then he's sweeping them up.
Right.
We just take that with those orange bins over, we just throw them in an orange
Gotcha.
bin.
No, it makes sense.
Yeah,
You just wouldn't want that contaminant in your aluminum.
Correct. And we have, normally we have a roller bin over here, like you can see over there. They get filled up like that as they're using it, they just go back over there and get remounted.
Gotcha.
And the rest of the garbage on the floor, you don't want,
Yep.
mixed with everything. I mean,
Absolutely.
if it's up here, you can usually take it, but if it starts getting on the floor, it's just garbage.
Right. It's not worth the headaches you're going to get from it being dirty.
Correct. Yeah. Absolutely. Now I can show you the rest of the shop, which is our zinc area. I mean, zinc portion of it. This is the aluminum section. Anything from here, number 3, all the way down is zinc. Sort of the real difference between zinc and aluminum, other than the material, is what we call the aluminum is cold chamber die casting, and zinc is hot chamber.
Okay.
Cold chamber being is that there is no the molten metal is separate from the die cast machine. The zinc machines have a pot which has the molten material built with the machine, and there's actually a plunger inside the molten metal. And as you saw with the aluminum, it's a separate process. You're actually taking the molten metal and transferring it over to a shot sleeve where the plunger shoots the metal in. In the hot chamber, as I said, there's a component called a gooseneck, and the plunger is inside the gooseneck. The gooseneck is basically like, with the plunger, I always say it's like a syringe. The syringe is inside the molten metal, or water, if you want to say. When the plunger comes up, the syringe pulls the plunger comes up like the syringe, pulls the water into the gooseneck or the syringe housing. Okay. Now it's filled with water and or metal. Yep. And as the die comes together, the plunger pushes down and pushes that material into the mold. Okay. So that's constantly inside a hot, molten, therefore hot chamber die casting. Gotcha. And you can't do that. You can't do that with the aluminum process because of the heat. And aluminum freezes quicker than aluminum does too. And there's the components in it wouldn't work because things would solidify.
Right. The temperatures and stuff doesn't work out.
That's why it's not done. But we don't shoot magnesium. But when they shoot magnesium, they have a hot chamber process, but the components are totally different. The gooseneck's made out of different material. It's very expensive to get into the magnesium die casting process. If you're a caster, right? Yeah.
So all those fancy engine components, that's why they're expensive.
Yeah, and it's very dangerous too, because you know anything about magnesium, you get water involved with it, right? Things will start exploding. Yep. So this is zinc. Show you. Let me show you. 450, this is a 250, this is a 450. And when you're walking, just watch out the sharpness. So you don't hit your arm. So we're just doing some maintenance on this machine. Clean it up, just paint it a little bit, do a little repair. But I can show you over here. This is zinc in here. Okay. It's obviously hard. It's not solidified. You can see this component back here. This is the gooseneck. Okay. The plunger is not in it right now, but the plunger gets attached to the shot cylinder and is dropped in here. And as I said, when this is molten, when the plunger returns to home, it sucks up molten zinc. We don't have there's normally a gooseneck that transfers between here and the mold. The gooseneck. I'll show you
Sure.
And then the mold is put inside the plastic in here, just like everything else, and then the metal transfer
on the T-rails. Yep.
These are our 30-ton machines, are automatic. so they're not running right now, but we do a lot of smaller components on here. So the same process you're shooting. This is zinc though.
Yep.
Zinc in here, run small, just on a smaller scale. Everything, and these are run automatically. And then our various trim presses for trimming different components.
Is there ever a case where like the customer doesn't want you to trim it, or
No.
I mean, because there'd really be no advantage, right?
No, because then I would have to sell them the whole thing with the metal.
Right.
So if you have a part, again, I'm just saying half a pound,
Right.
and like for instance, this.
You're buying that material if you're taking it.
They want you to get hurt. Feel the weight of this casting. That thing. Okay? Now, you get one handle is probably half a pound, but if I'm
Right.
selling you this, I'm selling you 5 pounds.
Right.
So
What's the
I mean,
point?
it might be like $30
Right.
versus $4. You know? So yeah, so everything is trimmed. And I wanted to show you this too. We do insert molding. That's a steel insert that the customer provides. We place that into the mold.
Okay.
And we overmold it.
Very cool.
Yeah.
Yeah, normally you see a lot of overmolding and plastic stuff, but
And that's zinc. And this is a handle for, I don't know, some cabinet or something. So we get these provided by the customer. As I said, we put them in the mold and we cast them. Trimming it over here. Handle. Nice feel the handle compared to what I got with.
substantially less weight than with all the other pieces.
Without really going in there, but he's actually casting them. So when he pulls it out, you'll see him insert the little insert. And that's the insert. And now he's going to start loading them up. We have a special tool that he puts them in.
Yeah, because I'm sure it's all hot in there.
Yeah. There's a little magnet inside there's an insert that's shaped as a square that holds it. And there's a little magnet that draws it in and keeps it in position so it's not rattling around.
Sure.
But the pressure of the cast or the metal coming in will push it home then. And that's then same process as before. When you open the door, you get your casting metal.
I was going to ask back on our trim die, how many? What's the tonnage of the press doing the trimming on our die?
That I think is 8 tons. 8 ton.
8-ton press?
Yeah. We have 8 ton, 15, and then we get into these bigger ones that are like 20. I think a bigger one over there is 20 to 30 ton, if I'm not mistaken. Yeah, that's as far as trimming pressure, that's nothing. I mean, what's on there. Yeah. But you know what? if there's something in here and we need to get your order out, it's not uncommon that we put it in there.
Sure.
Looks kind of stupid, but a little thing in there,
Yep.
but it'll work the same way, you know?
Yep. Still shearing it off.
Yeah.
Fantastic.
I can show you real quick if you're interested in what the shot sleeve looks like.
Okay.
Then we're done. This is the nozzle. Okay. This is in the machine between the gooseneck and the mold.
Okay.
So when the metal, and this is zinc, so when the metal gets pushed, from the gooseneck, gets pushed through here, into the mold, and then it makes the part. Now, we make our own nozzles here for our machines. Now these are the shot sleeves. So these are for the cold chamber. So this is the portion that sticks out from the back of the machine. That's the pour hole. And these are the plunger tips with the rod. So basically, it's not gonna. I'm just showing you.
Yep.
But this is basically inside here. Ooh, it actually fits. I don't want to get it stuck. Yeah, I don't want to get it stuck. But anyway, this is inside here, about that far back. The metal gets poured in here. As you saw, it was pushing this slowly to compact everything.
Yep.
And then at the end, it makes the final shot. And that's this portion from here is in your die, and that's where that biscuit comes out.
Sure. Right. That big that biscuit at the end.
Correct. So we have various shot sleeves for different customers. Depending if your die was unique, you would be owning one of these as well.
Okay.
But since yours is a unit die, we have our own master holders, and we have our dedicated shot sleeve that we have that go for that master holder.
Gotcha.
So that's something you don't have to purchase. But bigger dies like this, like this one here, which is the opposite side of this.
Okay. Yeah, that's a big guy.
We needed to get a shot. The customer had to buy a shot sleeve for that.
Gotcha.
Because sometimes we don't have the thickness of the A plate on the floor, the diameter of the plunger. So they have to purchase that as well.
Because I imagine it has to do a lot too with the fluid calculations of how quickly you can fill that and the volume of the amount of aluminum needed for the part.
Correct.
So, very cool.
That's it. Go back upstairs, then I'll bring one of your castings. You want one of the shots?
Oh yeah.
The full,
Yeah.
the
I'm
whole
gonna get one. I'm
thing,
gonna put one on
and
the
then
side.
Also all
Trim.
the trim pieces.
Yes. I'll give you one of those. I'm gonna go wash my hands. Liam, you want to take them back upstairs then? Okay.
Very
We'll
good.
be up there.
Well, thank you very much for the tour.
Absolutely, yeah. And I'll be upstairs in 5 minutes.
Excellent. Thank you. All right. So now here in the conference room, we've got a whole bunch of the parts all laid out in front. First of all, the finished part that we've already machined, and we've got. This is the casting trimmed. You can kind of see the finish is a bit different on there. And they blast it for us, and that is for better adhesion of the powder coating. And here was the part we saw down below with all the gates on it. And some of the waste in here, and along in the video here now with myself and Manny, we've got Eric, who did all the drawing for our product here. Eric and I own Magna-Matic together, so he usually doesn't get on much of the camera, but here we can talk about some of the technical aspects of the drawing and the project. And Eric, you had some questions about casting.
Well, like when casting, it's orientated this way to get the air up, I assume, right?
Correct. Yeah.
And then like
You could shoot it in this direction as well, but that would be more for if you had a two cavity or something. So if you had another one of these and you had the volume, this would be shot this way.
to get two in the same.
But and it's for air, and it's just for this how the tool is orientated in the machine. The size of the tool and the master holder and all that stuff gets put in that position. Normally, we like to shoot it going straight up for the placement of the tool in the machine.
We had some other questions about
It was
like
kind of
the volume and
overall on the machines themselves. It's everything's relative to the piston size for the volume of material you can push into a machine
Correct. Yeah, I mean, we
versus
usually
like the die size, right? Because your die you can get a little bit deeper, but then you can't shoot enough aluminum in. Obviously, our part's small, but how you kind of design around a part, or what's your maximum in that respect?
well, it starts out with the weight of the casting.
Okay.
Our machine we shoot this in a 450 ton. We can probably cast a 5-pound casting comfortably.
But that includes everything.
No, that's
Or-
the casting by
okay.
itself. And then you take the runner effect, so maybe you're maybe another pound or whatever.
Sure.
But then you have to know if it's a 5-pound casting and it's this big, then your die size is relatively small. But if it's a 10 by 10 casting and it's 5 pounds, then the die size wouldn't fit in our 450, and would be really tight in our 650 ton as well. I mean, that's just the surface area.
Yeah.
And then you have to take the surface area in consideration as far as the machine, the clamping pressure is going to be able to hold that surface area. If you have an area that's smaller, I mean, and you have 650 tons holding that clamping pressure there, it's a lot easier than having a 12 by 12 square, because then you've got
That's
a lot
real-
of it's
real
pushing
deep to get
yeah.
the material out of the other end.
So
too,
it's
right?
pushing a lot the surface area. With that being said, we normally shoot 2 3/4 inch plunger tip size. With most of our stuff here, we feel comfortable with that. Again, if because of the length of the shot sleeve, and you have a 5-pound casting, I might have to go to a 3 1/4 tip just because I have more material going in, and I can't use a 2 3/4 because I can't get that material in there
with enough time before
Exactly.
cooling and all the other
Well,
stuff, right?
Before you're filling up that shot sleeve.
Right.
Because there's only so much stroke too, right?
Correct. Yeah. Absolutely. Yeah. I think it's 20 inches. And you fill up. If you have, again, you're filling up 5-pound, molten metal in there. It's going to take up that shot sleeve relatively quickly. You might need a longer shot sleeve or a deeper, a thicker A plate to get more length on the shot. And then you start playing around with the tip sizes. But again, normally we use 2 3/4. Most of our size castings don't exceed, 10 inch square. Our stuff is relatively, what you have right here is normal to what we shoot as far as size wise for the casting itself.
Cool.
So in working, I mean, just another question to be an interesting point about this part. What were some of, because as you two work together, Eric doing all the drawing and stuff like that, and you guys doing all the, the fluid calculations and stuff like that, what were some of the unique things that you ran into, Eric, in drawing, and then also as you guys got the part, were there any kind of fun, unique challenges with this part, as well as a little background on it for the viewers? We used to have this casting as a permanent mold. Then for the last couple years, we moved to a sand casting, and then now we have moved to die casting. And a lot of that was because we were looking at getting really nice features of the lettering of the Magna-Matic blade balancer, because since we've been making this product since the 1950s, this bracket has become kind of iconic to the product. And when it came time to move to die casting and get better quality features, first, Eric, what did you have with some of the challenges you had with drawing it from the old part?
Well, the old part, I didn't have any drawings, so I had to redraw everything in the respect to even remaking all the lettering to what was originally designed, because there was no font to it. So that was all redone, but then also increasing the size.
You drew every single letter.
I drew every single letter, yes. And I rotated every letter and increased the size to get the inside of every letter larger, because we were talking back and forth and getting, you have to think, obviously, when you make a mold, there's a little tiny piece of steel in the inside of that A. And the bigger that can be, the stronger it is, the longer it'll last, and
Correct.
just problems along those lines. And then I believe we still made it out of a insert, right?
Yeah, the center portion of this casting is inserted in case we have to do any maintenance on it, rather than trying to weld up the main insert itself. we can remove the center insert and just either make a new one, which would be a lot cheaper, or just, when it's in your hand, it's a lot easier to work with than working on the mold, the big insert. It's
Yeah,
for
so-
maintenance purposes. We are able to pull this center piece out
Because
and work on
if
it.
something happened to an inside of
Correct.
any of the letters,
Yeah, and sometimes, like, as I said, you'd rather make it new than weld, because the weld doesn't last long. It's basically a Band-Aid. So again, rather than making a whole main insert again, we sub-inserted this so you can, for maintenance purposes and in the need to repair it or make a new one,
Yeah, so just to clarify so people understand, I mean, our whole die is the whole size of this, but there is almost a tool within a tool or a die within a die of these features so that they can take this piece out. If this would have to be remachined, they wouldn't have to machine the whole die, and that's the benefit of inserts.
Correct.
yeah, and just because of the lettering is relatively small. It's just a problem we've had for a very long time with this casting, and from the very start of the permanent mold, and then that company going out of business, and then now having to find a new thing, and here we are today.
Yeah. One of the other kind of fun challenges is when we added this, the American flag to the product, because we have seen a large increase in largely foreign or Chinese counterfeits of our product. We put the American flag in the casting, as well as cast USA and our signature M logo on the back of the casting as well. And also the castings will all have a year on the back now too, so you'll be able to see what year your balancer was cast. But when we did a sand casting, we had a flag as well, and one of the crazy things that happened is in the sand casting, they had bead blasted the surface again to get better adhesion for paint. But the sand casting company, when we designed the flag, didn't tell us that they were going to use a bead that was exactly the size of the stripes in the flag, and we were getting all kinds of beads lodged in the flag, which was making a machining nightmare and a cleaning nightmare for us. Made the part a lot harder to handle. So one of the things also too, you change the flag, so that'll be a difference. If you look at your balancer and the whole back of it is smooth, it was the sand casting where the new die cast one will have USA in the back with these logos, and the flag is also larger. So that was another thing that the flag had to change. And not only that, when we make a change like that, Eric has to think ahead about how he's going to machine it, and if he has tools to get into these small areas and not intersect with something else. I mean,
Yeah.
because we paint this part, and then in-house at Magna-Matic, we machine this away so that that silver contrast happens against the red. Again, Manny, thank you very much for the tour and letting us come in and see this. It was new for us to see die casting. We've been in different foundries, but never a die cast foundry before. And it's also nice to have Eric on this side of the camera once, so you can see who's designing and engineering all of the Magna-Matic products. So again, thanks guys for being in the video.
Thank you very
and
much
I hope
for
you guys
stopping by.
enjoyed it. If you can, please like and subscribe, and check out the rest of our videos. Thank you for watching.